Here we are with another video. We're going to look at negative and Pythagorean identities. So to begin here with the negative identities, you'll know these as the odd or even identities. Negative is used here because it's negative variables. So we know by this point that sine of negative x equals negative sine of x. That's one characteristic that makes it an odd function. And since that is true, cosecant of negative x equals negative cosecant of x, and we can see for cosine how it's even, and for tangent how it is odd. How tangent and cotangent of a negative value, that negative pops out front, whereas cosine or secant of a negative value, that negative value is disregarded. So let's try using this to simplify some expressions. So simplify into a single trig expression. So we know here that sine of a negative value, the negative pops out front, and then cosine of a negative value, the negative is disregarded. Okay, so we also see that we have sine of x over cosine of x, which simplifies to now just negative tangent of x, and that is simplified. So let's try another. Tangent of negative alpha multiplied by cosecant of negative alpha. So tangent is an odd function, so the negative here pops out front. And then cosecant is an odd function as well, so the negative there pops out front. Okay, so we're going to rewrite this now in terms of sine and cosine. So we have, let's see, wait. Two negatives. We're just going to, in our next step, the two negatives will disappear. They're going to cancel. So we have tangent of alpha, cosecant of alpha. Simplifying, sine alpha, cosine alpha, multiplied by 1 over sine of alpha. And with some simplification, we get 1 over, I was getting ahead of myself, 1 over cosine of alpha, which comes down to just secant of alpha. So simplifying to a single trig ratio. Not bad. This is a really good identity to use when you have negatives appear within your trig function. Knowing where that negative goes is very, very useful. So let's look at our second identity. Probably my favorite identity out of this whole entire unit. It is the Pythagorean identity. So it is the basic identity here. Sine squared of x plus cosine squared of x is 1. That's a beautiful thing. I do not have the time to explain where that comes from. So we know sine squared of x plus cosine squared of x is 1. And with this, we're going to extend this and say, okay, if that's true, then sine squared of x equals 1 minus cosine squared of x. So I'm just moving the cosine squared of x to the right. And then, in the same way, I can say, oh, well, cosine squared of x must equal 1 minus sine squared of x. Okay? So we now know what we can replace sine squared of x with, and what we can replace cosine squared of x with. And even better is if I take this Pythagorean identity and divide everything by, let's say, cosine. If I divide everything by cosine, we get a new set of identities. So we have 1, 2, 3 identities so far. Dividing everything by cosine squared of x gives us tangent squared of x plus 1 equals 1 over cosine squared of x, or just secant squared of x. So from this, we have an identity for secant squared of x. And then dividing everything by sine squared of x gives us, this is going to be 1, but we'll put cotangent, so we get cotangent squared of x plus 1 equals 1 over sine squared, or cosecant squared of x. So this is a truly amazing identity in my eyes. From one identity we can get 4 others, And then from this, I can say, oh, well, just subtracting 1 for each of these, we get another set. So subtracting 1, we would say, oh, well, tangent squared of x now equals secant squared of x minus 1. And cotangent squared of x equals cosecant squared of x minus 1. So there are some things that I've learned in the past that helps me remember these. For example, something I use here for secant squared is I tan by the c. So 1 plus tangent squared equals secant squared. And then I cotan by the coc. So 1 plus cotangent squared equals cosecant squared. That's just something I've learned. There are other mnemonic devices that help you remember these. But, you know, we'll have these in our notes, right? Because we're copying this down. So let's use this now. Use this in combination with other identities to simplify and verify some things. So reduce to a single ratio. So write everything in terms of sine and cosine. We've seen this before, this hot tip. Okay, so write everything in terms of sine and cosine. So in this, the first thing I'm going to do is get rid of this fraction appearance. So tangent of theta, cosine theta, multiplied by 1 over cosecant theta. Okay, so, all right, it gives us sine theta over cosine theta, multiplied by cosine theta. 1 over cosecant of theta, that's the reciprocal identity, is that that's sine of theta, knowing our reciprocal identities. So now some simplification, we get, cosines cancel. You have sine theta multiplied by sine theta. So in this, there are a couple ways. So sine theta multiplied by sine of theta, I could say that this is sine of theta squared, or sine squared of theta, okay? Not, let me use this in a different color, not sine theta squared, okay? That's a big no. Stay away from that. Either using sine theta parentheses squared or saying sine squared theta. This is the most commonly vocalized way of saying the answer, sine squared of theta. Just know this, it's not sine theta squared without the parentheses. Okay. That really did not use our Pythagorean identity. That's kind of boring. Let's see what else we have. So verify. Ooh, verify. Hot tip number 5, because 1 through 4 was given in section 1. Look for identities. So we now have expanded our identities. We're going to look for them. So in this, and there are a couple ways of doing this verification process. Okay. So we know to look to start with the more complicated side, which appears to be this side that we have. Okay. I'm going to show you real quick 2 ways of doing this. The first approach. This is actually fun stuff because there's more than one way. So 1 minus cosine squared is sine squared. Okay. So we were trying to verify that it equals tangent squared. So this is sine of x squared, cosine of x squared, which I'll just, for the fun, write it as this, and then the entire fraction squared, which is tangent squared of x equals tangent squared of x. So using a Pythagorean identity, we verified it. So another approach we could take, rather than that one, might take a little more work, it might not, is we see a fraction and split the fraction. So I'm going to say, okay, this will rewrite as 1 over cosine squared of x minus, cosine squared of x over cosine squared of x. Okay, I'm going to show that it's tangent squared of x. 1 over cosine squared is secant squared. We get 1. Remember with verifying, yes, we know from our Pythagorean identity, yes, we know that this is tangent squared, but we have to write that step. We have to show the step. So you use the Pythagorean identity in this approach, whereas it's a different identity than what we used for the first approach. 2 approaches getting the same end step. Let's try this one out. So this one's a little more chunky, I guess you could say. Verify that sine squared of u plus 2 sine u plus 1 divided by cosine squared of u is equal to 1 plus sine of u over 1 minus sine of u. So hot tip number 6, use algebra to make equivalent expressions. So again, this is having good algebra skills. For example, I want to tackle the left side because this looks like the more complicated side, having, well, more there. But when I look at sine squared of u plus 2u plus 1, what I'm seeing, maybe hopefully you are as well, I'm actually seeing here x squared plus 2x plus 1. And I can factor that. So that factoring that with sine of u is sine of u plus 1 multiplied by sine of u plus 1. Okay, and then also, let's do this just step by step. I was about to skip a step here. That's not good for verifying. Okay. So now I see cosine squared of u, and cosine squared of u using a Pythagorean identity is 1 minus sine squared of u. So 1 minus sine squared of u. I'm just going to leave this part blank and just carry it down at the end. All right. So again, we noticed before how we could factor it. Now this is something we hopefully notice. If not, I'm going to explain this here. There's something called difference of squares. That's like a squared minus b squared, and how it can be factored to a minus b, a plus b. So we have 1 minus sine squared. I'm going to factor that as, right in the top again, I'm going to factor that as 1 minus sine of u and 1 plus sine of u. Okay. Keeping our end goal in mind, I want 1 plus sine of u and over 1 minus sine of u. I feel like I'm very close now. Sine of u plus 1 is the same as 1 plus sine of u. I could just switch those two terms around. So we could say that we have a set that cancels, leaving us with, I'm going to rewrite it just so it looks like our right side, 1 plus sine of u, now over 1 minus sine of u. And through all of these steps, we get our end result. Verified. Okay, so this is probably the most complex verification problem we've had, just because of what was done within it. We saw our initial part as a quadratic, how we could factor, and we substituted using an identity, and then we saw that as a difference of squares. That's a hefty problem. Let's move on. So looking at verify. Cotangent of x times cosine of x plus sine of x equals cosecant of x. In this one, we could probably agree, left side is the more challenging one of these. So let's tackle it. Rewriting all of this in terms of sine and cosine is going to help us, I think. So cosine of x over sine of x. Okay. Notice I'm not rewriting the right side. Okay, I'm trying to make the left manipulate into the right. Okay, so now looking at this, we have cosine squared of x over sine of x. All right. How am I going to do this? Well, let's see. Oh, cosine squared of x plus sine squared of x. That's going to be 1. If I can get that together, that's going to be 1, which is going to help me here 1 over sine. So we can't add these right now. I have to have a common denominator. So we're going to combine fractions using common denominator. So this is over 1, so common denominator is sine of x, so cosine squared of x. That square's not there. What am I doing? That square's not there yet. Yet. So I'm going to multiply this now by sine of, now it's sine squared. Sorry guys. Now it's sine squared. I was getting ahead of myself. Over sine of x. Okay, and now cosine squared of x plus sine squared of x, that is 1. Which leads us to cosine of x equals cosine of x. All right, so I'm just going to put here for our note what I did. We use cosine squared plus sine squared equals 1. That's how we got from here to here. And that's always a good thing to do, to write in what theorem or what identity you're using, so when you get back later and look at it. And our last problem, verify. Verify, verify, verify. So this is another one. I've done this 2 ways. I'm going to show you just one. I encourage you, after I do this one and you follow through with me, pause it and try to do another approach. Take another approach in this problem. So in this, I'm going to use the identities. Let's see. I'm not quite certain. I'm going to tackle this right side. So I'm going to use the identity that tangent squared, that is secant squared minus 1. So, okay, tangent squared theta minus sine squared theta. I'm going to replace this, substitute in its counterpart, secant squared theta minus 1. And you're probably wondering, Mr. Beal, why did you choose to do that? Well, I chose to do that because knowing I can get a 1 from this, and knowing I have a sine squared, you could possibly see how getting this 1 from tangent, my sine squared is going to get us this minus sine squared. Now what's going to happen with this secant squared and how it's going to get us tangent, well, we'll see. So I'm going to distribute now my sine squared of theta, which gives us, let's see, tangent squared minus sine squared. So we get secant squared theta multiplied by sine squared theta minus sine squared theta. Second part of my problem's done. So now I need to simplify this. So secant squared theta is equivalent to 1 over cosine squared theta. Okay, so that gives us sine squared theta over cosine squared theta, which, using our quotient identity, gives us tangent squared theta minus sine squared theta, and here we go, we verified. There is an approach you could take, manipulating the left side, getting it to look like the right, but I'll leave that for you. So you're possibly wondering, in all of these verification problems, what is the answer? Because we already know that this left expression equals the right expression, that they equal each other. So what is the solution, Mr. Beal? the solution to verifying, the solutions are the steps. I'm gonna write this down. So in verifying, this is where we'll close. In verifying, the steps are the solution. So the solution to this problem is showing each individual step that leads us to our end result, proving that one expression is equivalent to the other. So I wish you the best of luck. Now that we have more identities to work with, that expands our problems that we can verify and simplify. So I wish you the best of luck in using these and solving your problems and application problems, and I'll see you in the next video.